Okay, my friends, let's talk about exponential function manipulation. Okay, so we're going to start off with some old school Algebra 2 stuff, our properties of exponents that we haven't used in forever, maybe even 5 ever, if you're that old. So we're going to start with things that look like this. Okay, we're going to start with an exponential equation in this form. And we want to change it to this form. Okay, so we're going to undo exponential addition. Right here we have addition going on in your exponents. We're going to undo it so that we can have an exponential equation in this form. So that there's no pluses and minuses up here, no horizontal transformations, but just rather a vertical shift. Right? Because in an exponential, this is where your horizontal transformations happen. They happen in your exponents, because that's where your x is. Okay? This is where your horizontal shifts happen. Anything horizontally is happening in your exponents with your x. And of course, it always happens opposite, like everything with x does. But that's our job today, is to take our exponential that looks like this, use our exponent manipulation to write it like this, so that there's no longer a plus, a minus, or a times in your exponent. Right? Because if we have a 3x here, this is a horizontal dilation. Right? We call these horizontal dilations. By a factor of, what's our dilation factor in this case? If we have a 3 here, but knowing that anything with x is always a liar, if we are multiplying by 3 in the x, it's really a factor of 1/3. Because anything with x is an opposite. Over here, when we had our plus, right? Which direction does a plus go when it's with x? To the left. So x plus 3 is a left 3 unit shift, or a horizontal shift left 3 units. It's always opposite. So this multiplication of 3x is actually a dilation by a factor of 1/3, right? It's a division problem. And our last one over here, what else is going on? Oh, this one right here, right? This is something that you haven't dealt with very often, but we will, and you'll become more familiar with it and know exactly what to do when you see it. This property of a negative exponent becoming a denominator as a positive. Okay? So there are some examples of what happens there. The negative exponent becomes a positive if it's in the denominator. Okay? Good to know. We're going to use that here in a second when we algebraically manipulate these problems. Okay, example 1. What type of a horizontal transformation are we talking about with each of these examples? Okay, so let's do that first. F of x equals 4 raised to the x plus 2 power. So what direction does our horizontal transformation go? Left. And how many units? 2 units. X to the x plus 2 and a power is a left 2 unit horizontal shift. Okay? It's always opposite. Usually these are with parentheses, but we don't often put parentheses in an exponent. So the 4 raised to the x plus 2 power is a horizontal shift left 2 units. Okay? Now we have 2 raised to the 3 times x power. So this becomes a horizontal dilation. Right? A horizontal dilation by a factor of, if it's multiplied by 3, then our dilation factor is a 1/3, right? It's a fraction, 1 divided by 3. So it's division. Horizontal dilation by a factor of 1/3. Okay, 9 to the x over 2, okay, is once again going to be a horizontal dilation because it's being multiplied. What are we multiplying by in this case? 1/2. So this is the same as x divided by 2, or 1/2 of x. So what is our factor of horizontal dilation? 2. Positive 2. So we're multiplying by 2. Horizontal dilation by a factor of 2, since we had a 1/2 as the power. And then lastly, we have 5 to the x minus 1. This is a shift to the right 1 unit. So every time we have a transformation happening in the exponent, right? That's always a horizontal transformation, and it's always opposite of whatever the sign or the operation happens to be. Okay, hopefully we remember that from Algebra 2. That happens a lot. Okay, so now let's get in with our algebraic manipulation. So we want to take our, actually, let's just do this. Here we go. 4 raised to the x plus 2 power, right? This is a horizontal shift of 2 units to the left. So we want to write this as sum a times b to the x. Okay, we want to take this as a horizontal transformation and change it into a vertical dilation. Okay, and we can do that with algebraic manipulation. So up above, plus came from what? Right, our power said if we have 2 things with the same bases that are being multiplied together, right? This is multiplication. We know it's multiplication because there's not a plus sign, there's not a minus sign, there's not a division sign. So this is 2 to the x times 2 to the 3rd. If we have the same bases being multiplied together, then we add their exponents. So we're going to take this addition of exponents and change it into this. So in other words, we have to add in this term. Or we're going to create this term. Okay? So what do we notice? Notice that it has the same base. If this is a 2, that's a 2. Right? If your base is a 4, that base is a 4. And notice else that the power is the same as the power that we have in your original problem. Okay, so we're not really creating anything. We are just rewriting it in a different form. So let's go down here and do that to this problem. This is 4 to the x plus 2. So my first term is 4 to the x times, what's my new term that I have to create? 4 to the 2nd power. Okay, it has the same base, so we have a base of 4 to begin with, which means I have a base of 4. And here's my x from my first part, and then there's my 2 from my second part. Okay, so now let's evaluate what is 4 squared. That's the number 16. So 4 squared becomes a 16, and we leave our other thing alone, right? This is 16 times 4 to the x. So that is now written as our standard exponential, right? Your initial term is 16. There's your 16. There's your a term. And we have b to the x power. Well, it has a base of 4 raised to the x power. We have done some excellent algebraic manipulation. Okay, so we are undoing these properties up above. Okay, here we have 2 to the 3 times x power. right? 3 times x. So we can rewrite this as 2 to the 3 times x, right? 2 to the third, that's our number, raised to the x power. Right? That was that property up above. If we have a number raised to a power, then we multiply these two things together. Okay? So we're basically putting parentheses around our 2 cubed. So what is 2 cubed? 2 times 2 times 2 is 8. So this is the same thing as 8 to the x. So notice we no longer have a horizontal dilation. We just have a normal exponential function through algebraic manipulation. Okay, 9 to the x over 2. So remember, x over 2 is the same thing as 9 to the 1/2 times x. Right? X divided by 2 is the same thing as 9 to the 1/2. Okay? So what we do is we put parentheses around these guys and we evaluate. What is 9 to the 1/2 power? So I hope you know that if you have something raised to the 1/2 power, that's the same as what root? The 1/2 power is the same as the square root. Okay? If you're raising something to a fractional power, then the denominator is your root. So we're looking for what is the square root of 9 raised to the x power. So what is the square root of 9? That's the number 3. So our exponential equation would just be 3 to the x. Okay? Now as an aside, what about the 1/3 power? What root is the 1/3 power? The cube root. Okay, which looks like this, right? The cube root has a 3 out in the elbow. And the 1/4 power is the 4th root. So whatever that power is, whatever your denominator happens to be of your fractional power, that becomes the root of whatever we're taking the power of. Okay, so if it was 10 to the 1/3 power, then that would be the 3rd root of 10. Or if this was 7 to the 1/4 power, that would be the 4th root of 7. Okay, so whatever the base is becomes the radical right there. Okay, just so you know, just a little aside, something that we haven't seen maybe in a while. Okay, 5 to the x minus 1. So we are going to add in a base of 5, right? We have to create the base of 5 for this one, and that's 5 to the -1 power. Okay, multiply. So we create a new base, raise it to that 2nd power. So what did we say about something raised to a negative power? We said that this will become a fraction. Anytime we have something raised to a negative power, it's going to become a fraction. 1 over 5 to the positive 1st power. Okay? So the thing that becomes positive is the power. So 1 over 5 to the positive 1st power. Now, do we have to put a 1 as a power? Right, we never have to put a 1 because everything is raised to the 1st power. But if that were a -2, if this were 5 to the -2 power, then yes, we would have a 5 squared in the denominator. But because it's only a 1, we just have a 1/5 there. Times 5 to the x. Okay, so something you'll notice, anytime we have a subtraction problem in your power, right, a subtraction in your exponent, you're going to have a fraction as your a value. Okay, a fraction as your a value. So let's see how we do. Right, so this is it. We have a horizontal translation, and you want to write it as a vertical dilation. Okay, so here are some more examples. So we're going to create, right? First we start with this base. So we start with 2 to the x, and then we add in a base, or rather multiply in a base to deal with our second term, our plus 3. Okay, so we have to add that multiplier. So now we evaluate what is 2 to the third power. And that is the number 8, and that goes in front of your exponent. Okay, in order for it to be an a times b to the x, you put your number in front and then your base to the x power. Okay, good job. All right, so once again we have a subtraction. So we start with our original base, which is 3 to the x, times our second base, which we create 3 to the minus 2 power. Okay, so we're going to apply that property that says we raise it to a negative power becomes a positive as a fraction. So that's 1 over 3 to the positive 2 power times 3 to the x. So now we finish our evaluation. 1 over 3 squared becomes 1 over 9 times 3 to the x. Okay, and because we are raising this to a power, we never multiply these things together, right? This is our base raised to a power. This is your first term. We never actually multiply them together. Okay? So our last problem, we're just going to manipulate this because this is your exponent. The 4 is not involved in our exponent. So it's just going to stay out here as a multiplier. So we deal with our first power, which is 3 to the x, times 3 to the second power, right? We have to create that second term with the same base. Okay? So now let's simplify. We have 4 and 3 to the x, but 3 squared is 9. So now I can actually multiply some things together. I can multiply my 9 and my 4 to get 36, but I don't multiply it by the base. So our final answer is 36 times 3 to the x. Okay, so we use algebraic manipulation and our properties of exponents in order to change a horizontal translation into a vertical dilation. Okay, with algebraic manipulation. Enjoy these types of problems. Goodbye.